Just like an equation is a mathematical sentence, an inequality is also a mathematical sentence, this time containing one of the following symbols: less than or equal to, greater than, or greater than or equal to. A solution of an inequality is a value for the variable that makes the inequality true. Look at the example, x is greater than -3. And let's circle the numbers that are solutions to this inequality. 4 is a solution to the inequality because 4 is greater than -3, as is 0. -5 and -3 are both not solutions because neither the -5 or the -3 are greater than -3. -2.9 is indeed a solution because if you picture a number line, -2.9 would appear slightly to the right of -3 on the number line, meaning that it's slightly greater than -3. For the example, x is less than or equal to 7, we would circle 6 as being a solution for being less than. The 8 is not a solution. 7 is a solution because our symbol states that it needs to be either less than or equal to, and 7 is equal to 7. -2 is a solution for being less than or equal to, but 7.1 is not less than or equal to. As you can see for inequalities, there are infinite numbers of solutions to these inequalities. So to state all of the solutions is a difficult task to do. To help us state all of the solutions, we often graph the solutions on a number line to help visually represent the solutions. Let's practice graphing inequalities on a number line. So for each inequality, let's indicate the solutions with a graph. Our first example is x is less than -2. To graph this, we begin by putting an open dot at -2, and then we shade all of the solutions, which would be all the values less than -2. Note that we use an open dot to designate that it's at that point, it is not a solution. 2 is not a solution to our -2 is not a solution to our inequality, therefore we use the open dot. To graph x is greater than or equal to 4, we begin by putting this time a closed dot at 4, and then shading all of the solutions, which would be our values greater than 4 on our number line. And note that we use a closed dot because 4 is a solution to the inequality. Our last example, 3, looks a little bit different, but we can see that there are actually 2 requirements here. X is greater than 0 and x is less than or equal to 5. So we begin by putting an open circle at 0 and a closed circle at 5 because it's greater than 0 but less than or equal to 5, and then shade our areas and our value in between these 2 points to show where our solutions are. Take note, and a general rule is that if you have less than or greater than symbols, these are all designated with open dots. However, if you have less than or equal to or greater than or equal to symbols, these will always be our closed dots on our number line.